Let's talk about blood indices, parameters that we're able to use to determine or to assess and interpret various blood components. So let's talk about first these and understand them before we go to the indices. So we have got hematocrit. If I get blood put in a test tube, centrifuge it, you are going to find that red blood cells are going to settle at the bottom. And in men, 47% of red blood cells will settle at the bottom, meaning that is the hematocrit value. How much red blood cells settles at the bottom. And in women, it is 42. If I get a microliter of blood, and then you count the red blood cells, you are going to find that in men there is 5.4 million red blood cells in a microliter, and then in women 4.8 million red blood cells in a microliter. We know red blood cells contain hemoglobin, a protein that carries oxygen. If I get a deciliter of blood, you're going to find that 16 grams is going to be hemoglobin in men, and then 14 grams is going to be hemoglobin in women. We need to know these values so that we are able to determine if the value that we find in a patient is correct or is within the normal range, or the patient is suffering from a certain condition. So let's start with color index, talking about now the blood indices. Color index is simply the ratio of hemoglobin concentration to red blood cell concentration. This value is a value between 0.85 to 1.15. If we find that the value is very much more than 0.85, that will mean that we don't have enough iron, because you can see hemoglobin is on top. So meaning if this value is small, it means that hemoglobin is less or iron is less. So that would mean person is suffering from anemia. So the other one that we should be able to talk about on the on the blood indices is the mean corpuscular volume, MCV. Mean corpuscular volume is simply telling us of what is the average volume of each red blood cell. So if I get a blood sample and then I just pick one red blood cell from there, what is the volume? Now they might not have the same volume, all of them, but that's what we're talking about, the average volume of a red blood cell. And we are going to find that it is 90 femtoliters. Now 90 is an exact value, so we can say from 80 to 100, 90 is just a mid value. How do you find the mean corpuscular volume? It is hematocrit, that is the amount of red blood cells in a blood sample, times 10 divided by the red blood cells volume. So what of if I have a normal value of the mean corpuscular volume? If a red blood cell has got a normal volume, that is called normocytic. If a red blood cell has got a smaller volume, less than 80 femtoliters, that is microcytic. A bigger volume, greater than 100, is called microcytic. So if you lose blood with a normal volume, that is called normocytic anemia, and that is due to conditions such as kidney problems or acute blood loss. For example, there's an accident that happens. If someone loses blood and they find that the blood which is lost has got a small volume, that might show that a person lacks iron, or it can be due to thalassemia, that is just a genetic condition, or it can be also to chronic diseases that affect the metabolism of iron. So, what of if someone loses blood that has got a very big size? That is mostly because of vitamin B12 deficiency. So, microcytic is related to iron, and then macro is related to vitamin B12. So we need to take note of that. Apart from B12 deficiency, vitamin B12 deficiency, there's also folate deficiency, alcoholism, and also other medical conditions. We also have the mean corpuscular hemoglobin, MCH. A mean corpuscular hemoglobin is just telling us how much hemoglobin is present in each red blood cell. And so it is the mass of hemoglobin present in each red blood cell. It is given in picograms. The normal value is between 28 to 31 picograms, and it is given by hemoglobin times 10 divided by red blood cells. Because we're talking about hemoglobin, that is why we're also using the hemoglobin on top. Okay, for the mean corpuscular volume, we're talking about volume of red blood cells. That is why we use hematocrit on top, because hematocrit is just a red blood cell count, right? So the value is going to be in picograms. Now notice that you always divide by red blood cell. This red blood cell, you're already assuming that you are already taking that it is in million. So meaning, for example, in men the value is 5.4 million red blood cells per microliter. Meaning I'll just get a 5.4, that is the one I'll divide by, and not a 5.4 million. So if I've got a low MCH, same with low MCV, that would mean microcytic. And that is mostly because of iron deficiency. And then if I've got a high MCH, that is macrocytic, and that is because of vitamin B12 deficiency, folate, and other conditions. Also alcoholism, liver diseases, hypothyroidism, and also bone marrow disorder. Now we'll go in the next video, we'll talk about different types of anemia. We'll talk about also the bone marrow disorder and how it gets to cause anemia. Okay, so this is on the MCH. And then we have got MCHC, which is mean corpuscular hemoglobin concentration. The difference between MCH and MCHC is that for MCH, we are just talking about how much hemoglobin is present in a red blood cell. But MCHC is how much hemoglobin is present in packed cell volume, in the whole red blood cells present in a given volume of red blood. I mean, in a given volume of blood. So if I have got blood, I know that about 35 to 45 is going to be packed cell volume, is going to be the red blood cells. Now, those red blood cells, all of them, how much hemoglobin is there? That is what we call mm, mean corpuscular hemoglobin concentration. Mean corpuscular hemoglobin in just one red blood cell, you find how much hemoglobin is there. So the normal value is 35%. If you have got, now this one is related to color. If I have got, I've not even talked about the formula. The formula is hemoglobin times 10 divided by hematocrit. You can see I've got hematocrit down. Why? Because we're talking about how much hemoglobin I have in packed cell volume, and packed cell volume is simply hematocrit. So this one is related to color. If the value is high, it means we're going to have a very high or dense color. The value here is small, then the color is going to be small or less, let me say, not small. Okay, so the normal value we have said 35, but we can also give it as a range from 32 to 36. If you have got a high value, that would be hyperchromic. If we have got a low value, that would be hypochromic. A high value is related to hereditary spherocytosis, and then a small value is related to iron deficiency, thalassemia, and also just other different types of anemia. Now, for the high value, we are talking of hereditary spherocytosis. What is really this hereditary spherocytosis? Now we know that the normal size of a red blood cell, or the normal shape of a red blood cell, is supposed to be biconcave. So in hereditary spherocytosis, red blood cells lose their shape, and so they end up being spherical in shape, and that is what we call the hereditary spherocytosis. And this one is because there is lack of a protein that is responsible for the shape of the red blood cells, proteins like ankyrin and spectrin. So we're going to find that you have got hereditary spherocytosis. Of course, you also have another condition called hereditary elliptocytosis. So the two proteins, ankyrin and spectrin, one more causes hereditary spherocytosis, another one more causes hereditary elliptocytosis. So these are the two conditions here. Okay. Now, let's consider this table here. If I have got a normal size of the red blood cells, and then a normal color, we call that as normocytic, normochromic. Normochromic means normal color, normocytic, normal size. If I've got a normal size but less red blood cells, that is going to be normocytic, hypochromic. If I've got a large size and a less color, macrocytic, hypochromic. if I've got a small size and less color, microcytic, hypochromic. So this is it. Let's consider this question. In the blood of a male subject, red blood cell count is 4 million counts per 4 million per cubic millimeter, which is the same as 4 million per microliter. And then the hemoglobin content is 8 gram per deciliter. Packed cell volume is 30%. Determine the color index, MCV, MCH, and MCHC, and name the condition. So, how do you get to determine these values? So let's start with the color index. Now, color index is given by hemoglobin concentration divided by red blood cell concentration. Hemoglobin concentration is simply the hemoglobin of the subject divided by the normal hemoglobin. Here the subject, the hemoglobin is what? Hemoglobin is 8. We'll divide by the normal. The normal that I gave for a male is 16. So let's divide that by 16 and then multiply by 100. That is a percentage of hemoglobin. And then red blood cell percentage, you get the red blood cells that you have. Here we have got 4 million, and then the normal we gave to say in males, the normal we gave was 5.4. And then we multiply this by 100%, and that will give us the color index. Now, let's get to punch this on the calculator. 8 divided by 16, this is 1 over 2 times 100, that is basically a 50%. And then in the denominator, we have got 4 divided by 5.4. And then that value we multiply by 100, that will give us about 74.07%. So then we'll divide 50 by the denominator, and that is going to give us 0.675 as a color index without any unit. Now we know that the normal range we gave was between 0.85 and 1.15. Let's go to the MCV. MCV, mean corpuscular volume, is given by the hemoglobin. All right, so sorry, not hemoglobin, because this is the amount of red blood cells, not the hemoglobin. So it is given by hematocrit times 10 divided by the red blood cells. Hematocrit for this subject, we are able to see that it is 4. Sorry, is that the actual value? No. Hematocrit is here, packed cell volume, which is 30%. And then multiply by 10 and then divide by the red blood cells. Now the red blood cells here is 4. So what would be MCV? 30 times 10 over 4, that is going to give us 75. We know the value is supposed to be in femtoliters. And then if we go to, okay, what was the normal value that we gave? We gave the normal value was between 80 and 100. And then MCH, because we're talking about a hemoglobin present in a red blood cell, then it is given by hemoglobin times 10 over red blood cells. So the hemoglobin here we can see is 8 times 10, and then the red blood cells is 4. Now I already said this value is, you only take this 4 because you already take that the value is in million per microliter. So this is going to give us 20 MCH. We gave it to say it is in picograms. And the normal value, what did we say? We said the normal value for MCH is between 28 and 31. What of MCHC? How much hemoglobin is in the packed cell volume is given by hemoglobin. Now you don't multiply by 10, instead by 100, and then divide by hematocrit instead of red blood cell. So you can see this one is the only one with hematocrit in the denominator. The others have got red blood cells. So hemoglobin is 8 times 100 over hematocrit. Hematocrit is what? 30. Okay. So then what will be the value here? The 0 can cancel with there. We have got 80 over 3. That will give us about 26.67. So then what is the normal value for MCH? We gave it, this is given as a percentage. That's why I'm multiplying by 100. So we said the normal value was 35, but we said it can be, we can give it as from 32 to 36 percentage to give us a range is better. So what condition is this? When you have got the color index, is the color index within the normal range? You can see it is below, and we said if the color index is below the normal range, that is anemia. And the opposite of anemia is polycythemia. So if it was high, we could think of that. What of MCV? MCV, you can see it is less than normal. Okay, because the normal is from 80 to 100. This is 75. So this would mean this is what? We said this is microcytic. What of here? It is still below. We said also for MCH, it is also microcytic. And then this one, it is also below. Now MCHC, we said it's related to color. This is hypochromic. So what condition is this? So this is microcytic hypochromic anemia. Microcytic hypochromic anemia. What causes microcytic hypochromic anemia? We've been mentioning this microcytic. We said this is related to iron deficiency. If it was macro, it is related to vitamin B12 deficiency. So we can look at this value. This is a test conducted for a certain person, and then these values were obtained. Now we are interested on these ones which are here, starting from hemoglobin up to here. You can see hemoglobin is 15.4. For this one, they've also given us a reference range 14 to 18. So meaning that this one is normal. The hematocrit is 45.2. They've given us also a reference. This is also normal. MCV is 90.2. They've given us a reference range. This is also normal. Okay. Now, we don't know if this is a male or a female. So I've just ticked this value. And I've also ticked just for the male there. We can see MCH is given as 31. The reference range for this one, they've given us between 26 to 31. This is also normal. What of MCH? It is 34. The reference range is also here. This is also normal. So meaning this person is normocytic, normochromic. So this is it for this video. Thank you so much for watching.